Good afternoon, guys. I'm going to work out the problems from your 7.5 to 7.8 test review after your new spring break. We will have our 7.5 to 7.7 test, or 7.8, I'm sorry. Again, I don't know exactly what that's going to look like because I don't think anybody really knows exactly what everything's going to look like right now, so just bear with us. I'll be available starting the week after spring break for you guys to ask questions and stuff like that on our Zoom app. I'll still be doing my videos and uploading them to YouTube so you guys can follow along with that as well. So we will get through this together, I promise. If I look at this first question, we're solving the system of equations and I'm asking you to practice using Cramer's rule. So that means we're going to have to find the determinant and then we're going to find d sub x, d sub y, d sub z. So the first thing I'm going to do is I'm going to rewrite my augmented matrix. So 1, 1, 1, negative 1. Then I have 1, negative 1, 5, and 5. And then 5, 1, 1, 19. So again, these first numbers in here are our coefficients. This category right here is our answers. So when we find our determinant the first time, we're just finding the determinant of our coefficient matrix. So we have 1, 1, 1, 1, negative 1, 5, 5, 1, 1, and then we are going to recopy the first two columns. So 1, 1, 5, 1, negative 1, 1. We're going to find our majors and our minors. So here, here, here. So my major would be 1 times negative 1 times 1 is negative 1. 1 times 5 times 5 is 25. And then 1 times 1 times 1 is 1. Minus, let's find, excuse me, let's find our minors. And that would be here, here, and here. So we have 5 times negative 1 times 1. It's going to be negative 5. 1 times 5 times 1, positive 5. And then 1 times 1 times 1, which is 1. So now we just do our simple math. I have negative 1 plus 25 is 24 plus 1 is 25. Minus negative 5 and a positive 5 is 0. Plus 1 is going to give me 1. So 25 minus 1. My determinant for my equations is 24. So now we're going to do the exact same thing, guys, but we're going to find d sub x. So when I do that, instead of rewriting the coefficients from my x column, I'm going to write the answers. So I have negative 1, 5, 19, then 1, negative 1, 1, then 1, 5, 1. And in order to compute this, we, again, remember, rewrite the first column. Guys, check every now and again, make sure that you have your signs correct, you recopied the numbers correctly, all that sort of thing. Because one tiny little mistake could make a huge, huge difference. So now let's find our majors. Here, here, and here. So when I figure this out, I have negative 1 times negative 1 times 1 gives me 1. I have 1 times 5 times 19, which is 95. And then I have 1 times 5 times 1, which is 5. Minus, let's find our minors. We have 1 here, here, and here. So we have 19 times negative 1 times 1, so it's going to be negative 19. 1 times 5 times negative 1 is negative 5. And then 1 times 5 times 1 is going to give me positive 5. So I have 1 plus 95, 96, plus 5 is 101, minus negative 19. So that obviously, guys, becomes a plus. So my d sub x determinant is 101 plus 19, which is 120. I'm going to do the same thing. I'm going to find d sub y. So I'm going to take my x coefficients, 1, 1, and 5. I'm going to take the answers now, negative 1, 5, and 19 for my y's, negative 1, 5, and 19. And then the coefficients for my z is 1, 5, 1. Now again, we go through the whole process. We're going to recopy the first two columns. So 115, negative 1, 5, 19. We're going to find our majors and our minors and subtract. So we're here. We have 1 times 5 times 1 is 5. Negative 1 times 5 times 25 is negative 25. And 1 times 1 times 19 is positive 19. Minus, when we go to find our minors, and we have 5 times 5 times 1 is 25. 19 times 5 times 1 is 95. And then 1 times 1 times negative 1 is negative 1. So now we'll just do our simple calculations. 5 minus 25 plus 19 is negative 1. Minus 25 plus 95 minus 1 is 119. So this will give me d sub y is negative 1 minus 119, which will give me negative 120. And now we're going to find d sub z. So we have d sub z. So coefficients for our x and our y's be 1, 1, 5, and then 1, negative 1, 1. So 1, 1, 5, 1, negative 1, 1. And then instead of the z column, we're going to put the answers. So negative 1, 5, 19. Negative 1, 5, 19. Go through the process. Recopy the first two columns. 1, negative 1, 1. Find our minors and our majors and subtract. So we're here. 1 times negative 1 times 19 is negative 19. 1 times 5 is plus 25. Negative 1 times 1 times 1 is minus 1. Minus 5 times negative 1 times negative 1 is going to give me 5. 1 times 5 times 5 is going to give me 5. And 19 times 1 times 1 is going to give me 19. So now we just simplify. Negative 19 plus 25 minus 1 is just going to give me 5. Minus 5 plus 5 is 10. Plus 19 is going to give me 29. So 5 minus 29 gives me, and that's going to be negative 24. So our d sub z is negative 24. And now to find our ordered pair, we just take all three of those numbers, the x, the y, and the z, and we divide them by the original determinant we got. So for x, I'm going to say 120 divided by 24, which equals 5. So my x value is 5. Then I'm going to say negative 120 divided by 24, and I get negative 5. And then I'm going to say negative 24 divided by 24 gives me negative 1. So my ordered pair would be x is 5, y is negative 5, and z is negative 1. And you plug it back in and check to make sure that you're right. Okay, moving along, guys. If you're going to do perform operations with matrices, if you are adding and subtracting, okay, remember in addition and subtraction, your dimensions of the matrix have to be the same. So a 3 by 2, you have to add it to a 3 by 2. Multiplication is when it's a little bit different, and we'll talk about that in a second. But this first question is asking me to say, okay, I'm going to multiply the whole A matrix by 2. So negative 3, 2, negative 1, negative 5, 0, 4. And subtract that from 4 times the whole B matrix. So negative 1, 2, 5, 3, negative 4, 8. All right, we can go ahead and do the multiplication. We can distribute that 2 to everything in that A matrix. So 2 times negative 3 is negative 6. 2 times negative 1 is negative 2. 2 times 0, 0. 2 times 2, 4. 2 times negative 5, negative 10. And 2 times 4 is 8. And then I have negative 4 times negative 1 gives me a positive 4. Negative 4 times 2 is negative 8. Negative 4 times 5 is negative 20. Negative 4 times 3 is negative 12. Negative 4 times 4 is positive 16. And negative 4 times 8 is going to be negative 32. But that's it. I can't not combine these anymore. And the reason why is this is a 2 by 3 and this is a 3 by 2. So we cannot do anything else. And the reason why is the dimensions aren't the same. So make sure you guys understand the reason why, and you tell me the reason why. So down here, I'm going to take 3, multiply it by everything in the A. So 3, and then A is negative 3, 2. That doesn't look like a 3. That doesn't look like a 2. Hang on. Okay, we have negative 3, negative 3, 2, negative 1, negative 5, 0, 4, minus 5 times everything in C. So that's going to give me negative 2, 1, negative 3, 6, negative 5, and 2. So when I multiply, guys, we're just distributing. So I have 3 times negative 3, negative 9. 3 times 1, negative 3. 3 times 0, 0. 3 times 2, 6. 3 times negative 5, negative 15. 3 times 4 is 12. Okay, guys, now at this step, I've told some of you, or most of you guys have told, I like to get rid of this negative right here. Let's just distribute this negative as we go through. This is going to become a positive. And now I'm going to say negative 5 times negative 2. That's going to give me 10. Negative 5 times 1, negative 5. Negative 5 times negative 3, 15. Negative 5 times 6 is negative 30. Negative 5 times negative 5 is positive 25. And then negative 5 times 2 is negative 10. And now we just have an addition problem. Since the matrix dimensions are the same, this is a 2 by 3. This is a 2 by 3. Since they're the same, we just combine the corresponding pieces. So I have negative 9 and 10. Negative 9 plus 10 is going to be 1. Negative 3 and negative 5 gives me negative 8. 0 and 15 is going to give me 15. 6 and negative 30 is going to give me negative 24. Negative 15, positive 25 is going to give me 10. And then 12 minus 10, or 12 and negative 10 is going to give me positive 2. And there's my answer. So now if I come up here, y'all look, we're multiplying. When we multiply, it's not that the dimensions have to be the same. There's a little different rule to it. So let's just write down what we have here. We have A, which is negative 3, negative 1, 0. 2, negative 5, 4. And I'm multiplying that by C, which is negative 2, 6, 1, negative 5. Whoops, forgot to write the 1. 1, negative 5, negative 3, and 2. So check your dimensions. This is a 2 by 3. The second one is a 2 by 3. In order to be able to multiply, these two middle numbers have to be the same. Are they the same? No. So that is the reason this cannot be performed. You can't do this one. Can't do. So now let's go to AB. I'm going to multiply A, which is negative 3, 2, negative 1, negative 5, 0, 4. And I'm multiplying that by B, which is negative 1, 2, 5, 3, negative 4, 8. So now let's check to see if we can do this. A is a 2 by 3. B is a 3 by 2. Check the middle. Are these the same dimensions? Yes, they are. So that means my answer is going to be in the form of a 2 by 2. Okay, so there's a little trick to this, guys. You got to pay attention to what you're doing. First thing we need to focus on is first row by first column. So I'm going to say, okay, negative 3 times negative 1 is 3. This is going to give us this position right here in our answer. Excuse me. Sorry, so negative 3 times negative 1, 3. Negative 1 times 2, negative 2. And 0 times 5 is positive 5. So 3 minus 2 is 1, plus 5 gives me 6. Now I'm going to go, same thing. I'm going to say first row, second column. That's going to give me this piece right here. So we have negative 3 times 3, negative 9. Negative 1 times negative 4 is plus 4. 0 times 8. Plus 8. So negative 9 plus 4 is negative 5 plus 8 gives me 3. Now we're going to work on the second row and first and second columns. Second row, first column is going to give me this piece right there. So I have 2 times negative 1, negative 2. Negative 5 times 2, negative 10. And 4 times 5 is positive 20. So negative 2 minus 10 is negative 12, plus 20 is positive 8. And now we say second row, second column. That's going to give me that piece right there. Again, 2 times 3, 6. Negative 5 times negative 4, positive 20. 4 times 8, 32. 4 times 8, 32. All right, so 6 plus 20 is 26, plus 32. And then I got 58. So there's your answer. All right. Along. Same sorts of things. Now we're talking about inverses. And it says determine if B is the inverse to A. Show all of your work. Well, if you're going to show that something is an inverse, we have to create the identity matrix. I'm going to multiply A times B here, and then I'm going to multiply B times A over here. So I say 5, 3, 3, 2. And then I have 2, negative 3, negative 3, 5. So first row, first column. 5 times 2 is 10. 3 times negative 3 is negative 9. 10 minus 9 is 1. First row, second column. 5 times negative 3 is negative 15. 3 times 5 is positive 15. I get 0. Second row, first column. 3 times 2 is 6. 2 times negative 3 is negative 6. So I get 0. Second row, second column. 3 times negative 3 is negative 9. 2 times 5 is positive 10. Negative 9 plus 10 is 1. We have created the identity matrix right here. So now we multiply the other way. Instead of A times B, we're just going to do B times A. We got to check if we create the identity matrix again, then we've proven that they're inverses. So B is 2, negative 3, negative 3, 5. And A is 5, 3, 3, 2. So first row, first column, 2 times 5 is 10. Negative 3 times positive 3 is negative 9. So 10 minus 9 is 1. First row, second column, 2 times 3 is 6. Negative 3 times 2 is negative 6. 6 minus 6 is 0. Second row, first column, negative 3 times 5 is negative 15. 5 times 3 is positive 15. I get 0. Second row, second column, I get negative 3 times 3 is negative 9. 5 times 2 is 10. So I get 1. So I have proven that, yes, they are inverses because I got the identity matrix both times when I multiplied forwards and backwards. So here, if we're going to find the inverse of the matrix, 2 things we have to find. First, we need to find the determinant. I'm going to say A times D minus B times C. So A and D, those are my majors. It's negative 5 times negative 2 minus 1 times 4. So negative 5, negative 2 is 10 minus 4. My determinant is 6. So in order to find our matrix inverse, we have 1 over our determinant, 1 over 6. And then when I set this up, I switch the places of majors. So negative 5 and negative 2 switch spots. And then I change the signs of the minors. So 1 becomes negative 1 and 4 becomes negative 4. And then to find the inverse, I just distribute or multiply by 1/6, divide by 6, however you want to look at it. So I have negative 2 6 is the same as negative 1/3. 1 6 times 1 is negative 1/6. Negative 4 divided by 6, or negative 4 times 1/6 is going to give me negative 2/3. And then 1/6 times 5 is going to be negative 5/6. And there's your inverse. All right, here they ask us to use Kramer's rule again. It's pretty straightforward and simple when you just have 2 equations. This process moves pretty quickly. Again, we're just practicing, so I'm going to write my augmented matrix. I'm going to write my coefficients of x, which are 3 and 1. Write my coefficients of y, which are 1 and 1. And my answers, negative 9 and negative 7. So to find D, we just use our coefficient matrix. So 3, 1, 1, 1. Multiply 3 times 1 is 3. 1 times 1 is 1. So 3 minus 1 is 2. So if I'm finding d sub x, instead of using my x coefficients, I use my answers. And then I have 1 and 1 for my y's. So major, negative 9 times 1 is negative 9. Minus my minor, negative 7 times 1 is negative 7. So this becomes negative 9 plus 7. So d sub x equals negative 2. And then d sub y, same thing. In the x column, I'm going to use my coefficients of x, 3 and 1. In the y, I'm going to use my answers, negative 7 and negative 9, negative 7. Multiply our majors, so 3 times negative 7 is negative 21. Minus our minors, 1 times negative 9 is negative 9. This obviously becomes plus, so my d sub y is negative 12. So to find my answers, my x and y value, I'm going to take the d sub x, which is negative 2, and divide it by my determinant, which is 2, so x equals negative 1. And then I'm going to take my y, d sub y, which is negative 12, and divide it by 2, and I get negative 6. My ordered pair would be negative 1, negative 6. Same thing here. Let's write our augmented matrix. So I have 3, 7, negative 4, positive 4, and then 10s for my answer column. So my coefficient matrix would be 3, 7, negative 4, positive 4. So my major is 3 times 4, which is positive 12, minus the minors, negative 28. Well, negative 12 minus a negative 28, that's going to become plus. So my determinant equals 40. So now I'm going to find d sub x. I'm going to replace my x value coefficients with the answers. Keep the y's. So my major is 10 times 4, which is 40, minus the minors, which is 10 times negative 4, which is negative 40. So this becomes 40 plus 40, so d sub x equals 80. Now to find d sub y, I take my coefficients of x, 3 and 7. I put my answers in the column for my y. Major would be 3 times 10, which is 30, minus the minor, 7 times 10 is 70. So d sub y equals negative 40. And then to find my answers, we simply say, okay, d sub x is 80 divided by 40. 8 divided by 4 is 2. D sub y is negative 40 divided by 40, so I get negative 1. So my answer is 2, comma, negative 1. All right, we're going to use Cramer's rule again. Again. This is obviously with 3. So this is just a long process, but nothing you guys can't handle. Let's write our augmented matrix first. So 1, 3, 2. 1, negative 1, 1. Negative 2, negative 5, 2, and then our answers are 2, 8, negative 7. So to find my determinant at the beginning, I'm going to use just my coefficients. So I have 1, 3, 2. 1, negative 1, 1. Negative 2, negative 5, positive 2. Now I rewrite the first two columns. So, 1, 3, 2. 1, negative 1, 1. I find my majors and my minors, and I subtract. So major. 1 times negative 1 times 2, negative 2. 1 times negative 5 times 10, negative 10. Negative 2 times 3 times 1, negative 6. Minus, let's find our minors. Here, and here. So I have 2 times negative 1 times negative 2 is going to give me 4. 1 times negative 5 times 1 is negative 5. 2 times 3 times 1 is positive 6. So now we just do some simple calculations, guys. Negative 2 minus 10 is negative 12. Minus 6 is going to be negative 18. Minus 4 minus 5 is negative 1. Plus 6 gives me 5. So negative 18 minus 5 is negative 23. It's my x, my determinant, I'm sorry. So now to find d sub x. Okay, I'm going to write answers in the first column for x, 2, 8, negative 7. Then I have my y coefficients, 1, negative 1, 1. My z coefficients, negative 2, negative 5, 2. Rewrite the first two columns. So 2, 8, negative 7, 1, negative 1, 1. Find my majors and my minors and subtract. So major, major, major. I have 2 times negative 1 times 2 is negative 4. 1 times negative 5 times negative 7 is positive 35. And then negative 2 times 8 times 1 is negative 16. Minus my minors. Minor, minor, minor. Negative 7 times negative 1 times negative 2. It's going to be negative 14. 1 times negative 5 times negative 2 is negative 10. 2 times 8 times 1, 16. So now we just do some basic math calculations. Negative 4 plus 35 minus 16 is going to give me 15. Minus negative 14 and negative 10 plus 16. And that gives me negative 8. So then I have 15 minus a negative, so 15 plus 8. My d sub x equals 23. So now I find d sub y. Again, so I put my x coefficients, 1, 3, 2. My answers, instead of the y coefficients, 2, 8, negative 7. Then my x coefficients, negative 2, negative 5, 2. Perform the operations by first rewriting the first two columns, 1, 3, 2, 2, 8, negative 7. Take your major, 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 major. So 1 times 8 times 2, 16. 2 times negative 5 is negative 10 times 2 is negative 20. Negative 2 times 3 is negative 6 times negative 7 is positive 42. And then you find your minors. Minor, minor, minor. 2 times 8, excuse me, times negative 2 is negative 32. Negative 7 times negative 5 plus 1 is plus 35, times 1 I mean. And then 2 times 3 is 6, times 2 is 12. So now we just have our basic simplification. 16 minus 20 plus 42, which gives you 38, minus negative 32 plus 35 plus 12, which gives you positive 15. So 38 minus 15, d sub y equals 23. Now d sub z. Guess what? We're going to do the same thing. I'm going to write the x coefficients, which are 1, 3, 2. 1, 3, 2. The y coefficients, 1, negative 1, 1. And then instead of z coefficients, I write my answers. So 2, 8, negative 7. 2, 8, negative 7. In order to perform these operations, again, we're going to recopy the first two columns. So 1, 3, 2. 1, negative 1, 1. Find our majors and our minors and subtract. So major, major, major. 1 times negative 1 times negative 7 is 7. 1 times 8 times 2, 16. 2 times 3 times 1, 6. Minus my minors. Minor, minor, minor. 2 times negative 1 times 2, negative 4. 1 times 8 times 1, 8. Negative 7 times 3 times 1, negative 21. So 7 plus 16 plus 6 is 29 minus negative 4 plus 8 minus 21. Negative 17. So I have 29 plus 17, which gives me positive 46. So d sub z is 46. Now to find my ordered pair, guys, you take your d sub x, your d sub y, your d sub z, and you divide it by your determinant, which was negative 23. So I have 23 divided by negative 23, 23 divided by negative 23, and 46 divided by negative 23. So my ordered pair is negative 1, negative 1, negative 2. And there you go. Okay, back to our operations with matrices. So I'm going to do these questions for you again. Guys, remember, if you're adding or subtracting, it's important that the dimensions are the same. So in this first question, they're telling me to take the A matrix, which is this one. I think I cut it off, sorry. And you're going to multiply 4 by everything in the A matrix. So 4, 7, negative 1, 3, 7, 5. minus 5 times everything in the B. So B is negative 4, 8, 6, negative 3. So when we perform this, 4 times 4, 16. 4 times negative 1, negative 4. 4 times 7, 28. 4 times 7, 28. 4 times 3 is 12. 4 times 5 is 20. I have negative 5 times 4 is 20. Negative 5 times 6 is negative 30. Negative 5 times 8 is negative 40. Negative 5 times negative 3 is positive 15. I cannot go any further because the dimensions aren't the same. Okay, multiplying, I don't need the dimensions to be the same. When I put them together, when I set them next to each other, we'll say, so I have 4, 7, negative 1, 3, 7, 5. And then C is negative 5, 6, 4, 7, negative 4. How did I do that? 9. My first matrix is a 2 by 3. The second one is a 3 by 2. These numbers are the same, so my answer is going to be a 2 by 2. So let's just perform this and be done with it. That's awesome. First row, first column. So 4 times negative 5 is negative 20. It's going to give me this spot right here, guys. Negative 1 times 6 is negative 6, and 7 times 4 is positive 28. So negative 20 minus 6 is negative 26, plus 28 gives me 2. Now I have first row, second column. So 4 times 7 is 28. Negative 1 and negative 4 is positive 4. And 7 times 9 is 63. So 28 plus 4 plus 63 gives me 95. Give Mommy one more second, please. So now second row, first column. 7 times negative 5 is negative 35. 3 times 6 is 18. And 5 times 4 is 20. So if we have negative 35 plus 18 plus 20, I get positive 3. Then second row, second column. So 7 times 7 is 49. 3 times negative 4 is negative 12. And 5 times 9 is 45. So 49 minus 12 plus 4 is 82. So there you go. There is our answer. Now I go down here, and to show that A and B are inverses, that means, guys, remember, we have to multiply A times B to see if we get the identity matrix, and then B times A. Yeah. So my A is 2, 5, 1, 3 times B, which is 3, negative 5, negative 1, 2.
1, 2.
1 second, baby. So I say first row times first column. 2 times 3 is 6. 1 times negative 5 is negative 5. 6 minus 5 is 1. First row, second column. 2 times negative 1 is negative 2. 1 times 2 is positive 2, so I get 0. Oops.
Oopsie.
Real careful, baby.
Oopsie poopsie. That's funny.
Oh, that is funny. Okay, second row, first column. 5 times 3 is 15. 5 times 3 is 15. Yeah, so 3 times negative 5 is negative 15, so I get 0. Second row, second column. 5 times negative 5 is negative... Sorry, 5 times negative 1 is negative 5.
Mommy,
6 and 2.
Mom, who you say sorry to?
I'm trying to talk to the kids so they can learn how to do this. Okay, give Mommy 5 more minutes. Negative 5 plus 6 is 1. So there we've created the identity matrix. Now we're going to do the exact same thing, but I'm going to multiply B times A. So B is 3, negative 5, negative 1, 2. A is 2, 5, 1, 3.
2, 5, 1, 3.
So first row, first column, 3 times 2 is 6. Negative 1 times 5 is negative 5. 6 minus 5 is 1. First row, second column, 3 times 3. 3 times 1 is 3. Negative 1 times 3 is negative 3, so 3 minus 3 is 0. Second row, first column, negative 5 times 2 is negative 10. 2 times 5 is positive 10, so you get 0. And then second row, second column, negative 5 times 1 is negative 5. 2 times 3 is 6, and I get 1. So there's, we proved right there, guys. Yes, they are matrices. They're inverse of each other because you got the identity matrix. Now if we're going to try and find the inverse, we first have to find our determinant. So that's going to be my A times D minus B times. So majors, 9 times negative 6 minus 7 times negative 8. So 9 times negative 6 is negative 54, minus 7 times negative 8 is negative 56. So this becomes plus, so my determinant is 2. So I have 1 over 2 equals, and now we have to get our matrix set up to do our inverse. So my majors switch spots. So negative 6 goes here, 9 goes here. My minors switch signs. So positive 7 becomes negative, negative 8 becomes positive, and now we just distribute that 1/2, or we divide everything by 2. So I have negative 6 divided by 2 is negative 3. 8 divided by 2 is 4. Negative 7 divided by 2, we can just leave as negative 7/2. And then 9 divided by 2, we can leave as 9/2. And there's our inverse. Okay, so here, guys, we're going to just use Kramer's rule to solve. I have my x coefficients are 5 and negative 1. My y coefficients are 4 and 1. And then my answers are 2 and negative 22. So to find my determinant, I take 5, negative 1, 4 and 1. I have my major, 5 times 1 is 5, minus my minor, which is 1 times 4, which is negative 4. So 5 plus 4, D equals 9. So D equals 9. I'm just going to, on the same page, I'm going to do everything here. All right, so D sub x, we're going to use my answers, so 2 and negative 22. My y values are 4 and 1. So my majors, 2 times 1 is 2, minus negative 22 times 4 is negative 88. So 2 minus negative 88 is going to give me D sub x is 90. And then for D sub y, I'm going to use my x coefficients, which are 5, negative 1. And my answers, which are 2 and negative 22. So my majors, 5 times negative 22, it's going to be negative 110 minus negative 2. So I have actually negative 110 plus 2 gives me negative 108. So D sub y equals negative 108. So I'm going to take 90 divided by 9, comma, negative 108 divided by 9, and my ordered pair is 10, comma, negative 12. Okay, these next Kramer's rule ones, I feel like we are a little redundant on this. So if you guys have questions on this, when we meet in our Zoom meetings, you can go ahead and ask. But I'm just going to work the last... these last examples here, just to go through, you guys know how to show if they're inverses or not. I'm going to do these two, to where it says find the inverse, and then any other questions you have, we'll go through the Zoom. So first thing I'm going to do is AD and BC. So my majors are negative 7 times negative 18 minus 4 times 33. So we have positive 126 minus 134, so my D equals, not 134, it's 132. So my D equals negative 6. So I'm going to take 1 over negative 6, and I'm going to get my inverse all set up. So my majors switch spots, so negative 18, negative 7. My minors switch signs, so negative 4, negative 33. So, negative 18 times negative 16 is positive 3. Negative 33 over negative 6, we can simplify by 3. So this becomes positive 11 over 2. I have negative 4 over negative 6 becomes positive 2/3. And then 7 divided by negative 7, negative 6 becomes 7/6. So there's your inverse. Here, same thing. I'm going to do A times D minus B times C. So my majors are negative 8 times negative 9 minus negative 12 and negative 6. Negative 8 times negative 9 is positive 72 minus negative 12 times negative 6 is positive 72. So I get 72 minus 72. My determinant equals 0. So guys, if you didn't recognize this right off the bat, if you went to set up your matrix to get your inverse, I'd put a 0 here. We'd switch our majors, so it'd become -8, -9, and this would become +12 and +6. But you cannot have 1 over 0. This becomes undefined. So your answer here would be that there's no inverse. So guys, again, we're going to have the 7.5 to 7.8 test at some point in that week after spring break. I'm just not sure exactly what day it's going to be yet or how we're going to do it. So I will definitely post that during the break so you guys will have ample time to study. And we'll have at least one Zoom meeting at that point where we can figure out exactly what we're doing. You guys have any questions, you can go ahead and ask me. So I hope you are all staying safe and healthy. And if you need anything, just shoot me an email. Thank you.